Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. We are from Group 1. We present about our group project GEOTECHNIC 1, which is soil classification. For our content, we will present about introduction, problem or case study, literature review, application of the test, discussion and conclusion.
Assalamualaikum and hello everyone. My name is Muhammad Anishazwan bin Adi. My matric number CF240242. Today we are excited to present our group project on soil classification, a critical topic in geotechnical engineering. Soils in nature are not usually found as pure gravel, sand, silt, clay or organic matter. Instead, they are mixtures with different proportions. This variability makes accurate classification essential for understanding soil behavior and ensuring it's suitable for construction. Inaccurate soil classification can cause major problems such as unstable foundation, poor drainage and excessive settlement. For example, soils with high clay content or poor gradation can reduce bearing capacity and lead to structural failures. To prevent these issues, engineers use methods like sieve analysis, hydrometer tests and attribute limits tests to classify and predict soil behavior. These tests are guided by standards like USCS and H2, which ensure consistency and accuracy. Accurate soil classification not only solves issues like instability and landslides, but also ensures the design of safe and durable structures. By using these reliable techniques and standards, we can address challenges effectively and build stronger and safer projects. That's all from me. Now I will pass to my group members. Thank you.
Hello Dr. Nasi, I'm Elijah Ruben. My matric number is CF240359. Today I'm going to present about the case study. We have studied the case about landslide, the Hulu Langat landslide which struck Kampung Gahal in Selangor, Malaysia, which has happened on May 21st, 2011. There are a lot of problems that caused this landslide to happen. Firstly, weathered granite composition. The slope was mainly weathered granite, lead to decreased shear strength and slope failure under saturation. Secondly, intense rainfall. This saturated the soil, increasing pore water pressure and weakened the soil structure. Thirdly, poor drainage systems. This system failed to redirect water, leading to water accumulation and made the soil unstable. Fourthly, increased soil weight. Saturated soil became heavier, adding stress to the slope. Next, decreased soil cohesiveness. Water saturation reduced cohesion between soil particles, weakening internal friction and making the soil more prone to sliding. Next, rise in pore water pressure. Water infiltration raised pore water pressure, disrupting soil cohesion. Moreover, structural weakness and cracks. Long-term water exposure caused soil compaction loss and cracking further, compromising soil stability. And the last one is hindered rescue efforts. The size and volume of debris made rescue efforts difficult. Thank you, that's all.
My name is Brenda Ichi Anak Simon. My matrix number is CF240160. I'm going to present about literature review for our project. So for the first one is environmental and geological background. Slope collapse and soil saturation results from the schist and worn granite that make up Hulu Langat's mountainous terrain, which is prone to instability, particularly during periods of excessive rainfall. Next is overview of the event. 16%, primarily children, were murdered in a landslide that occurred at an orphanage in Hulu Langat on May 21, 2011. Structures next to high-risk slopes are vulnerable because of the primary causes, which were excessive rainfall and inadequate slope management. The third one is environmental and human factors. By weakening slope, human activities like deforestation, unchecked growth, and inadequate drainage raise the risk of landslides. The vulnerability of the orphanage was further increased by its location at the foot of a steep hill. Last but not least is strategies for risk management and mitigation. Slope control, reforestation, and early warning system are examples of effective risk management that can lessen the effects of landslides. The disaster brought attention to the need for more stringent land use regulation and improved urban planning and future landslide risk management requires a multidisciplinary approach. That's all from me.
Assalamualaikum. My name is Nur Ain Izati binti Abdul Rahman Mani Selvan. My message number is CF240099. I will present about application of the test. There are three subtopics that I will present. First is laboratory and classification system. Second, field application using classification system. And lastly is practical recommendation. Let's go to the next slide. This slide explains Unified Soil Classification System or USCS, which is widely used in geotechnical engineering. This system focuses on two key properties of soil. First is particle size and second is plasticity. It categorizes soils in two main types. First is coarse-grained soil such as sand and gravel, and second is fine-grained soil like silt and clay. In the Hulu Langat case, the weathered granite soil with high plasticity, which is CEH, the soil characteristics are significant because of their ability to retain water, which can lead to poor pressure build-up and contribute to slope failure. So, another classification system we use is the H2 soil classification system, which is particularly focused on soil suitability for road construction and slope stability. This system categorizes soil based on particle size and consistency, ranging from A1 until A7. In the Hulu Langat case, the soil was classified as A7, which is fine-grained soil with poor drainage properties. To address these challenges, better drainage system and efficient slope management techniques are essential. H2 help determine the necessary measure to handle high-risk soil like those found in the Hulu Langat. Slide describe the laboratory methods used for soil classification. First, we collect soil samples from affected areas. Then, we conduct grain size analysis using sieve and hydrometer tests to measure fine particles. Next, consistency tests. Consistency tests like at-the-bird limit are performed to determine the soil's liquid and plastic limit. The results are used to classify soils such as identifying high plasticity clay STH in the USCS system. So, accurate soil classification is critical for understanding soil properties and ensuring safer engineering design. Now, let's look at how soil classification tests are applied in the laboratory, in the field, and for practical recommendation. In the lab, we conduct grain size analysis and consistency tests like at-the-bird limit to classify soils using systems such as USCS and H2. In the field, this classification helps identify high-rise areas such as steep slopes and waterlogged soils. The results are used to design better drainage systems and install monitoring tools such as piezometers to measure pore water pressure. These steps are crucial for improving structural safety and preventing slope failures.
My name is Nurin Christina and I will present about the discussion. Why soil classification matters? Soil classification is important because it helps us identify risky soils for construction and slope stability. For example, in the Hulu Langat landslide, weathered granite soil became unstable after heavy rain, leading to a disaster system like USCS and H2 help us predict soil behavior and plan better. Next is challenges. There are challenges with soil classification. Lab tests like sieve analysis don't always reflect real-world conditions, especially during extreme weather. That's why we need to combine lab test results with tools like piezometers for more accurate predictions. Next one is practical solutions. We can solve these issues with a few key solutions, such as install drainage system to prevent water build-up. And second one, use materials like geosynthetics to stabilize weak soils and monitor the soil in real time with tools like piezometers for early warnings. Lesson that we can get from this discussion: the Hulu Langat landslide showed us what can happen without proper planning. Poor drainage and soil mismanagement led to loss of lives. It reminds us to take soil studies and risk mitigation seriously to avoid similar disaster. And lastly, For future steps, looking forward, we can use technology like AI to improve soil classification and predictions. Combining this with real-time monitoring tools will help keep people and structures safe. By working together, we can reduce risks and prevent future tragedies.
Alright, my name is Sean Akipinsha Ismail. Alright, I will continue for the last part for this project presentation is conclusion. Alright, the Hululangan landslip highlight the importance of correct soil classification in geotechnical engineering to minimize slope instability risks. Factors such as granites, lower shear strength, severe rainfall, and inadequate drainage system contribute to the disaster. Engineers can use established systems like the H2 soil classification system and the unified soil classification system to evaluate soil quality, accept weakness, and develop preventative measure. Real-time monitoring technology, artificial intelligence, and machine learning can further enhance categorization frameworks and soil behavior forecasts. The case study underscore the need in the disciplinary approach combine sound geotechnical procedure, urban planning, and advanced technology solution to ensure infrastructure safety and sustainability in exposed area. Alright, that's all from me. Thank you for watching and thank you very much.